piece, what you're going to be doing, it's going to be using your calculator. So I wanted you to see this, number one, because I need to make sure that everyone knows how to use their calculators and knows how to do this like basic pieces. I'm hoping that most of you have seen this before, but if you haven't, that's okay. Some of you this will just be review, and that's awesome. But for some of you, it's not, so I don't want to go too quickly on this. So we're going to use scientific notation all semester. You're going to use it if you take any other science, if you take biology, anything you do, nursing, you're going to be seeing scientific notation everywhere. And so we need to be really good with understanding how to read it. And so why do we even use scientific notation? We use it because in science, we have crazy big numbers and crazy tiny numbers. And writing all those zeros is just impractical. And so that's why we use scientific notation, because it really helps us understand kind of the magnitude of the numbers, like how big or how small they are. So for example, if you have a red blood cell, instead of writing all these zeros, we use these numbers, right? And we're going to talk about what these exponents are. And so, for example, so these numbers of scientific notation, and they're always between 1 and 10. So what I mean by 1 and 10, so the number in front of the multiplication sign is always going to be like 1, 2, 3, 4, 5, 6, 7, 8, or 9. It's going to be one of those, right? Between 1 and 10. The exponent, that's the number of places you moved your decimal. If this is negative, that means your original number was less than 1. If it's positive, your original number was greater than 1. Now, a lot of times people say, oh, well, if it's negative, I move my decimal this way, and if it's positive, I move my decimal that way. You can remember it like that, but in my experience, what happens when we try to remember rules and we're under pressure, we're not sure which way it's supposed to go, right? And we get stressed out. So I think it's easier if you just remember bigger than 1 or smaller than 1. Okay, so what do I mean by that? So here's a number 35,000, right? So when we do this 4 means the number was bigger than 1, and we moved our decimal place 4 places. So we went from 3.5, and we moved our decimal place 1, 2, 3, 4 places. If it's negative, it means it's smaller than 1. Again, this one says we moved our decimal place 4 places, but we moved it to make it smaller than 1. So here is our decimal place, 1, 2, 3, 4. This number is smaller than 1. So you're going to move it in the direction to make it smaller than 1. So again, all of these are positive, meaning that number was greater than 1, right? So it's a greater than 1, so make sure you have your decimal place in the correct way. And again, between 1 and 10, between 1 and 10, between 1 and 10. Okay, now if we look at this, here's our exponents. All of these are negative exponents, meaning our number was less than 1, right? So it's just telling us the number of times to move our decimal place, making sure that our original number is less than 1. Okay, so now if we put these into scientific notation, remembering that our number needs to be between 1 and 10. So when we do this, and I'm totally fine if you actually just put these numbers like this. So this would be 1.14 times 10 to the negative 2. The reason it's negative 2 is because this number is less than 1. So this, here's going to be 1.4. When we move this, I'll just start here, 1, 2. We're moving it 2 places, but this time it's going to be a positive 2 because it's greater than 1. So I want you to see these two look kind of similar, but they are not similar at all because of the negative here and the positive here. So now, for this one, C. For C, we're going to move our decimal place 1. And so when we do this, we get 3.632 times 10 to the 1. I get this question all the time. Do you need the 1 there? Yes, you do need the 1 there, right? So that means you moved the decimal 1 place. Okay, so now this one again would be an excellent reason of why we use scientific notation. So here's our original decimal place, and we're going to move it 1, 2, 3, 4, 5, 6 places. And so when we do this, we're going to have 9.8 times 10 to the negative 6. And again, it's negative 6 because this number is less than 1, right? And we're going to be putting pretty much all of our numbers in scientific notation for the rest of the semester. Now, I get the question like, oh, when do we have to put it in scientific notation? When don't we have to put it in scientific notation? If it's a really big number or a really small number. So I would have been okay if you left this in scientific notation. I would not have been okay if you left that in scientific notation. And we're going to talk about those a lot. Okay, so now here's the part I want to spend like just 5 minutes on this. We need to teach you how to use your calculator. This is probably the most important 5 minutes of the entire semester because for some reason, calculators seem to be a very big issue for us. So if you have your calculator, I need you to look at your calculator, and what you're looking for is you're looking for the EE button or you're looking for the exponent button. So if you have your camera, you might want to put your calculator up there and then I'm going to help you use it. So now a lot of times people use the caret button. So when you have this in your calculator, there is a scientific notation button that is right in your calculator, and now my pen's not working, that you need to learn how to use, or on your quizzes and your exams, you're off by usually a good factor of 10. So show you how to use this EE button. So if you have a graphing calculator, you're going to put 6.78 EE 3. That is what that number should be in your calculator. This EE, this means times 10 raised to the. So if you use these pieces in your calculator, the times 10 and the caret, 60% of the time you'll get the right answer, and the other 40% of the time you might not. Now, some of you might actually have a button that says EXP. And in that case, you're going to put 6.78, push the EXP button, and then 3. So I want you to try to do that, and I want to see that you get this number. So I'm going to change this here so I can see everyone, to see if you can get that number correctly. And if when you're doing these problems in lecture and you are not getting the answers we're getting, literally on this slide, take a picture of your calculator and just send it to me. I have used so many calculators, I can pretty much tell you the way your calculator works. For example, some of your calculators are going to need excessive numbers of parentheses. Some of your calculators aren't going to need any, right? It just depends on the type of calculator you've got. So try this first one, and then try this one. And I want to see that you can get these answers. And if you're not getting these answers, again, either take a picture of your calculator and send it to me. If you have a graphing calculator or a TI, usually the number, the EE you're looking at, is right above your 7. And it's usually going to be second function, comma, if you've got a graphing calculator. And then it's lovely. But again, what we're not going to do is we're not going to put in our calculator the times 10 raised to the, right? The calculators are actually not designed to do that. They're designed to use this EE button, which again, or exponent button, depending. Okay, so is everybody getting this answer in their calculator? If you do not have your calculator right now, you must try these in your calculator, because we're going to be using these calculators to do these complex calculations from now until the end of the semester. And the most frustrating thing is when you know how to do the chemistry, but not how to use the calculator, and then you continually get the wrong answers. It's very frustrating. When you use the EE or the exponent button, so it'll be either EX, it'll be one of these 3. So when you do this, it's 6.78 E, this 3, or 6.78, that button 3, 6.78, that button 3. You don't put times and you don't put 10. Just that button and then the number 3, right? Okay, so work on these. And again, if you're watching this later, please, please, please put these in your calculator using, I think those are the 3 variations on the numbers that I see. If you've got the calculator that's gray, green, and white, you have to use parentheses. So with your calculator, I want you to try this one. So let's see if you can get this one with your calculator. And if not, we will go through it again. So see if we can get this one. So try this. And again, depending on which calculator you have, you will notice that the parentheses is very important, right? And if you do not get this on your calculator, this is what I want you to do for me. I want you to take a picture of your calculator right now, whether you're watching this now or watching this later. If you are not getting 7.41 times 10 to the negative 4th on your calculator, I want you to take a picture of your calculator and send me a picture. Okay, so everyone try this. If you do not get it on your calculator, send me a picture and I will help you figure out what's going wrong. And I want to see like what you actually entered in your calculator, right? That's how I can tell what you're entering in incorrectly, because every calculator works so differently. If you don't know how yours works, that can kind of be very challenging for the next couple of months. Okay, so again, make sure you get this here in your calculator. And if you do not, text me a picture of your calculator with you entering that in, and then I will help you figure it out. Okay, so now we're going to continue on. We're going to talk about precision versus accuracy. So these 2 definitions you're going to need to keep in your mind because we use them in lab a lot, and we'll also have them on your quiz and your exam this semester too. So precision, this is just how many times you get the same answer, right? So like if you were to weigh something on your balance and it said like 1.01 grams, 1.01 grams, 1.01 grams, that would be precise. You're getting the same answer again and again. Oh, okay, sorry. Somebody want to take a picture of this? Yes. Here you go. Put this back here just so everybody can have it. And again, this should be on your lecture notes too. Okay, so now precision, how many times you get the same answer again and again, right? So that is our precision, which is different again than accuracy, because accuracy is how close you are to the right answer. So let's say you put something on your balance and it said 1.01, 1.01, 1.01. You weighed it 3 times and you got the same answer every single time. But let's say it was supposed to say 2 grams. Right? So you were precise because you kept getting the same answer, but you were not accurate because it wasn't the correct answer, right? So accuracy is how close it is to the correct or true or accepted value. So correct value, true value, or the accepted value. So how close you are to actually being correct. So precision, how many times you get the same answer. So you get the same answer again and again and again, versus accuracy is how close you are to the correct or true answer. So using horseshoes, because it works well, you've probably seen it with darts before. So this one would be like accurate and precise, because right, accuracy would be like actually getting a horseshoe. I don't know what that's called, but when you actually make the horseshoe work, I'm sure there's a word for it. This one would be precise, right? Because it keeps landing the exact same place, but definitely not accurate because nowhere near where the actual target is. This would be me playing. Neither precise nor accurate over here, not anywhere near close to where it's supposed to be, and like randomly thrown everywhere. So hopefully that will help you with your accuracy versus precision. Okay, so next thing we're going to do is talk about significant figures. So in your OLI book and in many books, there are all these rules, and you have to memorize all these rules to figure out significant figures. Well, I've simplified it so you don't really need to remember any rules. You really only need to remember one thing, and that is the United States and where the Pacific Ocean is and where the Atlantic Ocean is. Okay, so just bear with me for a second and this will all make sense. So, right, the Pacific Ocean is over here by California, and the Atlantic's the one over by New York, right? If the decimal place is present, then you start from the Pacific Ocean side and you count all the numbers beginning with the first non-zero number. And I'll give you an example of this in just a second. If the decimal place is absent, meaning there's no decimal place, you start from the Atlantic Ocean side and you start counting again with the first non-zero number. Now, important when we're doing these significant figures, once you start counting, you never stop. Now I'm going to show you what that means. Okay, here's our number, 0.00350. First question is there a decimal place? Yes, there is a decimal place. So therefore, if the decimal place is present, we start from the Pacific Ocean side and we count every number, but we start with the first non-zero number. This is a 0, this is a 0, this is a 0. That is not a 0. So we start from the Pacific Ocean side and we start counting with the first non-zero number. So we don't count 0, don't count 0, but now we start counting. Once we start counting, we don't stop, meaning we have 1, 2, 3 significant figures. And you will always see me abbreviate this to sig figs or SF. You see SF, that's me talking about significant figures. Okay, so every time we do a calculation in chemistry, we need to take into account significant figures, right? And so this is how we take them into account. We're going to talk about why they're important in just a few minutes. Okay, so again, decimal place present, start from the Pacific Ocean side, starting with the first non-zero number, and then you just keep counting. This has 3 significant figures. Let's look at another example. It's like this number, 4,600. There is no decimal place, right? There's no decimal point, so that means our decimal point is absent. So we start from the Atlantic Ocean side, and we start counting with the first non-zero number. This is a 0, doesn't count. This is a 0, doesn't count. Not a 0. This is our first non-zero number, so we keep counting, and therefore we have 2 significant figures. Okay, so again, if the decimal place is present, start from the Pacific side, starting with the first non-zero number. Absent, start from the Atlantic side. Okay, so let's try these. So in all of these, there's a decimal place present. So these are all going to be Pacific side. Now, this number here, right? This number here, a nice thing, this is in scientific notation. In scientific notation, if you have any numbers before the multiplication sign, these are all going to be significant because this is the decimal place is present, right? And so we don't look at this when we're trying to figure out significant figures. We only look at before the multiplication sign. So for our first one, right, decimal place present. So we start here, 1, 2, 3 significant figures. Again, our second one, decimal place is present. So we start from the Pacific side with the first non-zero number. So doesn't count, doesn't count, doesn't count. 1, 2, 3 significant figures. Again, decimal place is present, starting from the Pacific side. 1, 2, 3 significant figures. Again, once we start counting, so once you put that number 1 down, you count every number until you're done with the number. So for example, with this one, not a 0, so we count here, 1, 2, 3, 4 significant figures. Okay, so let's try a couple more here. Okay, so try these And you can either type them in the chat or just write them down. And then we're going to go over them and we'll go over them in like 30 seconds. Maybe I'll give you a minute. So try these and then we'll go over them in like a minute. Okay, so again, we'll go through these. And there's no decimal place on this one, right? Oops. And then we're going to put it into scientific notation too. So for this one, no decimal place. So we start from the Atlantic side. 1, 2, 3, 4 significant figures. Now, if we put this into scientific notation, remember when we're doing scientific notation, the number in front of the decimal place has to be between 1 and 10, meaning it has to be 1, 2, 3, 4, 5, 6, 7, 8, or 9. So if we're going to put this one into scientific notation, we have to put a decimal place here because the number in front of the decimal place needs to be between 1 and 9. And so 7 is between 1 and 9, so we have to put it after the 7. Now, again, when we do this, 7, here was our decimal place, right? So we went 1, 2, 3. So it's 7.032 times 10 to the positive 3. And again, this is a positive 3 because this number is bigger than 1, right? If it was a negative 3, then it would be smaller than 1. Okay. Now our next one, we look here again, here this time, we have a decimal place. So we start from the Pacific side, starting with the first non-zero number, 1, 2, 3. It has 3 significant figures. So now we see it has 3 significant figures. I'm going to put this into scientific notation. Very important. However many significant figures you have to keep the same number. So we have 3 significant figures here. So when we put this into scientific notation, we still have to have 3 significant figures. So I'm going to put my decimal place here because that's, again, between 1 and 9. So I'm going to move it 1. So this ends up being 8.80 times 10 to the, I moved it 1 time. Now, the reason, here it is in that light and much nicer, we have to keep this 0 here because if we don't, this only has 2 significant figures. This had 3. We have to keep the same number of significant figures, right? And so we have to keep it 3. Now for C, how many significant figures does C have? Again, starting from the decimal place is present. So we start from the Pacific side, starting with the first non-zero number. Well, this is a 0, doesn't count, doesn't count, doesn't count, doesn't count, doesn't count, 1. This has 1 significant figure. Now, if we're going to put this into scientific notation, remember the number in front of the decimal place needs to be between 1 and 10. So 5 is our only option. And then we just count how many times we move our decimal. 1, 2, 3, 4, 5. So it would be 5 times 10 to the negative 5. And the reason that this is negative right here is because this number is less than 1. right? So that's why it's negative, because it's smaller than 1. Now, an incorrect way to write this would be like this. The reason this would be incorrect is because this has 2 significant figures, but this number only has 1 significant figure. So we can only have 1 significant figure. So whatever number of significant figures we start with, we have to have the same number in the end. Okay, so saying that, what is wrong with this answer? I'm going to put right here. And let's see here. Oops. What is wrong with that answer? Right? I'm hearing it and seeing it all over in the chat. Yeah, this number here, so if we do the significant figures, right, doesn't count. 1, 2, 3, 4. This has 4 sig figs. That means that when I rewrite it, this also needs to have 4 sig figs. We can't change the number of significant figures. It's kind of like if you had a scale at home, right? And if you had a scale at home and it only read like, so these are your only options. It only read to the 50s. So you either weighed 100 pounds, or you weighed 150 pounds, or you weighed 200 pounds. Right? So let's say you weighed, I don't know, 156 pounds. That's how much you actually weighed. Actually, let's do 154 pounds. If you weighed 154 pounds, actually, right? But you went on the scale, all you would know is that you weighed in between. When you were on your scale, it would read 150 because it would round down, right? Because 154 is closer to 150 than it is to 200. So it's like, you don't know. All you know is to that point, right? And so you only have this significance here of these 2 significant figures. If you weighed yourself on this scale right here, remember this is your actual weight, and you said, I weigh 154.25 pounds. Based on this measure right here, you'd be like, how in the world do you know that, right? Because all this scale tells you is you weigh 150 pounds. There's no way these numbers mean anything. So these significant figures, they're determined on the precision of our instrument. So let's say you had a scale. We're going to change our scale. Let's say it only went to 1s. So I'm say, so you had 151, 152, 153, 154, 155. So let's say it told you weighed 154 pounds, okay? And you're like, I do weigh 154 pounds, but let's say you actually weigh 154.25 pounds. Right? So all you would know if you weighed yourself on this scale is that you were in between 154 and 155, right? That's all you know. So all you know is to the precision of this number here. You don't know beyond it. If you said, oh, I weighed myself on the scale and it says I weigh 154.1 or 25 pounds, there's no way you would know that from this scale. All you know is that you're in between 154 versus 155. Now, the same thing, if you had a scale that had better precision, and it could say 154.1, 154.2, 154.3, 154.4, and again, we're going to say this is your actual. Now, if you weighed yourself on the scale, it would say 154.2, right? Or it might even round to 154.3, but this scale has much more precision, right? And so now you're up to 4 significant figures. And so that's why we keep the same number of significant figures as whatever you started with. So we're going to keep talking about why we use those. And when we get into lab, we're going to talk a lot more of those. Okay. Now, there are some rules we need to talk about significant figures really quickly. So there's 2 sets of rules. there's multiplication, division, and there's adding and subtracting. So when we're multiplying and dividing, which we do very often in chemistry, we always need to look at the significant figures when we write our answer down. So the last thing you should do in every single problem in chemistry is go, are my significant figures correct? That's the last thing you do. You don't really need to think about it until then, but the last thing we should do is think about our significant figures. Okay, so let's give an example of multiplication and division. So here's the problem. An object has a mass of 5.342 grams and a volume of 7.9 milliliters. What's its density? So if we just do density equals mass over volume, and we have these numbers, what we would do is we'd put into our calculator. This is from like the 1970s, and it would give us this number. Okay, from this number, we need to determine how many significant figures we can actually use in our answers. So when we're doing multiplication and division, our answer can have no more significant figures than any number that's used in the calculation. So what we do is we look at the numbers we've used. So we have two numbers here. We have 5.342, which has 4 significant figures, right? Starting from the Pacific side, 1, 2, 3, 4 significant figures. And we have 7.9, again, decimal place present, 1, 2 significant figures. Our number can only have the same as the least. So since this one has 4 and this one has 2, our answer can only have 2 significant figures. And so what I suggest when we do this is draw a line, and that kind of tells us. And then we have to look here at this number 3. The 3, if it's 4, 3, 2, or 1, it says leave this one alone, which this one is. And if it's 5 or above, we round up. And we'll talk more about what that is. But since this is a 3, that means our answer is just 0.67 grams per milliliter. Right? And this is with multiplication and division. So let's look at adding and subtracting. So multiplication and division, it's the least total, right? But with adding and subtracting, it's the least precise. So let me talk about what least precise means. Okay, so let's say you have a book, a box, and a piece of paper. Now I want to know what's the height of this stack. So you put it in your calculator and it says 219.187. But when we're doing adding or subtracting, our answer can only have the same number of significant figures as the least precise measurement. So how do we know what the least precise measurement is? The least precise measurement is the one with the fewer numbers after the decimal. So you see how this one has 2 numbers past the decimal? This number has 1 number past the decimal. This one has 3 numbers past the decimal, right? The least precise is the one with the least numbers after the decimal. So this only has 1 number past the decimal. That means our answer, that didn't really add very well. Let me just move that. We can only have 1 number past the decimal. So when we do this, we can only have 1 number past the decimal. So, and then we see this 8. This 8 says round up. So when we round it, it'll round to 219.2. Okay, so let's try a few of these. So remember, multiplication and division, least total. Adding and subtraction is the least precise, meaning when we're doing adding and subtracting, we only look after the decimal place for our significant figures. Okay, so we're gonna try a couple of these. So I'm gonna put this in my calculator. And here's what my calculator says. And what I want you to do while I'm doing this is to figure out how many numbers I can actually keep and then what the actual answer is. So I'm just going to do all of these. This one's interesting. I'm not going to write the rest of the phrase. Okay, so I put these in my calculator, and this is what they said. So when we do these, we need to decide, first of all, what rule is this? So this is a multiplication rule. So it's the least total numbers. So this number has 2 sig figs. This number has 3 sig figs. So this number can only have 2 sig figs. So when we do this, I'm going to keep those 2. And then I'm going to look, this one says leave it alone, don't round up. So my answer would just be 0.21, 2 sig figs. All right, let's look at B. This one has 4 sig figs. This one has 2 sig figs. That means my answer can only have 2. Well, I'm going to keep those 2, right? This is a 5. This 5 says I have to round my 7 up. So when I do this, I get 58. Okay, let's try this is adding and subtracting these next 2. So now I'm only going to look past my decimal place. So this number has 3 digits past the decimal place. This number has 2 digits past the decimal place. Well, I only have a 5, but I have to have 2 digits past my decimal place. So it should be 5.00. Because again, when we're adding and subtracting, we're only looking past the decimal place. Okay, again, this is adding and subtracting here. So we're going to only look past the decimal place. This has 1 past the decimal place. This one has 3. And this one has 2. That means we can only have 1 number past our decimal place. So I'm going to draw my line here. This 6 says I need to round this up. So when I do this, I get 20.2. Okay, we're going to have to do this for every single calculation we do in chemistry forever. So every time we do a calculation in chemistry, our calculator is going to give us a bunch of numbers. We need to decide how many of those numbers we can actually use. So this is kind of like the fundamental for the rest of the semester. Every time, just think of every single time you use your calculator from now on, you're going to need to do this with your significant figures. Okay, so those are just all the answers in a much neater way than I had them. Okay, so let's see how we're doing on these significant figures. We're going to practice some. So how many significant figures? So you can either type this in the chat or just write it down. How many significant figures are in 24? See how fast we can do those. And again, feel free to write it down. You don't need to type it in chat, or you can do it privately. So it's not such a bad one, right? I agree. 2. How about in 3001? How many significant figures are in this one? Seeing a lot. Yes, yes. Yep, this one has 4. Okay, next one. How many significant figures in this? Seeing a lot of correct answers, right? Decimal place is present. These 2 are pretty easy because they don't have any zeros in them really, right? Or on the edges. So this one again, doesn't count. 1, 2, 3 significant figures. Okay, how about this one? This one's a little trickier, right? Remember, when we see in scientific notation, all we're doing is looking before that multiplication sign, right? You don't need to expand it out. You don't need to rewrite it. You're just looking before the times 10 to the sign, right? So this one has 2 significant figures. Okay.
Professor, so for like number 3,
Yes.
we only ever count to 0 if it's after a whole number between 1 to 9 as a significant figure?
Yes, there's no decimal places. Yes, there's no decimals. Okay, how about this last one? This one's a little trickier. So here's my question for you. Is the decimal place present or is the decimal place absent? It's absent, right? So since the decimal place is absent, we're going to start counting from the Atlantic side, starting with the first non-zero number. So this is a 0, it doesn't count. 1, 2. This has 2 significant figures, right? So when we're doing significant figures, the first question we ask ourselves is the decimal place present or absent? Remember, if it's present, you start from the Pacific side, starting with the first non-zero number. If it is absent, you start from the Atlantic side, starting with the first non-zero number. Now, again, if you read in your OLI book or a lot of books, there's like 9 rules. You are welcome to memorize all 9 rules, or you can just remember present Pacific, absent Atlantic, and that's all you have to remember. Okay, but again, it's totally your option, but no matter what, we have to think of these and we need to identify our significant figures every single time we use our calculators. Okay, now, exact numbers are numbers that are known with certainty, like counting numbers. Like if I said there are 12 oranges, right? There's not 11.67 and we rounded, or 12.21. No, there's exactly 12, right? You can't have quarters of an orange. Well, I mean, you could, but we'll do eggs. If I said 12 eggs, you can't have quarters of an egg, right? That's just not even possible. Or for example, number of sides on the square, there's exactly 4 sides on the square. Or defined numbers, and our defined numbers, we're going to see these are numbers that we use for what we call our unit conversions. They usually have an equal between them. So we don't use these when we're looking at our significant figures. We'll use them in our problem, but we're not going to use them in our significant figures. So both defined and counting numbers have unlimited numbers of significant figures. Like, for example, this is what I mean. If we talk about sides of the square, there are 4 sides to the square. Well, technically, I could say 4.00000000000 to infinity sides to a square, right? That's supposed to be an infinity sign. So technically, it's an unlimited number of significant figures. So there's so many of them. There's always more significant figures here than any other. So we never use those when we're doing a calculation. Here's an example of that. Okay, so if we were going to do the average of 3 lengths, we would just add these up and divide by 3, right? And so here's what our calculator tells us. Here is the answer we get. The reason is, so if we look here, this has 2 places past the decimal, 2 places past the decimal, 2 places past the decimal, but we are dividing by 3. But 3 in this case is a counting number, meaning we have 1 length, 2 lengths, 3 lengths, right? We don't have 3.15 or 2.98. This isn't a rounded number. This is an exact number. We have 3.00000000000 to infinity, right? That makes this one have so many more significant figures than either of these two. We don't use it in our calculation. So if it's a counting number, like 12 eggs or 3 books, right? A number that we're actually counting, or something that comes from a unit conversion, and we'll talk more about those. Those have equal signs in between them. We don't use those when we're trying to figure out how many significant figures we have. We're only using the significant figures that are used in our data, and I'll show you what that means. So we don't use 3 again because it's an exact number, and it has unlimited numbers of significant figures. Okay, now rounding, just to review, so we're all on the same page. If the digit to removed is less than 5, leave the preceding digit alone. If it's greater than 5, round up. This is a very important piece right here. In a series of calculations, you carry the extra digits all the way to the end and then you round. Don't forget to add placeholding zeros if necessary. Okay, so what's going to happen in chemistry is we're going to have, sometimes we're going to be doing like 3, 4, 5 different calculations in one problem. If we round in between every single calculation, by the time we get to the end, our answer is going to be so far off from what it should be. So we don't round until the very end. Okay, now let's look at what placeholding zeros are. Okay, so let's say that, I don't know, you won the lottery and you won $6,875, right? Woo! And you put that in the bank, and the bank said, we're going to round that to one significant figure, just one, and we're gonna round off the rest. So if we rounded this to one significant figure, and I rounded that to 7, and the bank's like, we've deposited your $7. You'd be a little upset, right? If you put in $6,875 into the bank, and the bank said, okay, I'm gonna round that to one sig fig and put $7 in, right? You'd be like, where's the rest of my money? This is what I mean by placeholding zeros. You can't round $6,875 to $7. It rounds to $7,000. Now, if the bank did that, you'd be like, yay, I just made extra money, right? Because we rounded up. This is what I mean by placeholding, right? $7 is not the same as $7,000. So remember, you have to keep the same value of the digits, right? So 6,875 rounds to 7,000, not 7, right? So that's what we mean by placeholding zeros. Okay, so let's just do just a couple of roundings. So we're gonna round these to sig figs. And so I'll do the first 2 with you. And then I'm gonna have you do these, and then we're gonna go over these. So 3 sig figs. So I'm gonna keep 1, 2, 3, and that's where I think it really helps to just like draw a line, because it just is a mental picture of, okay, that's where I'm gonna end. And then you look here, this is 5 or greater, so that means we round up. So this would round this up. So this would be 1.01, right? For our next one, 1 sig fig. This is the one I'm going to keep here. I can't draw a straight line. Close enough. The 6 says round up. So this would be 0.007. Okay, so I want you to try 3, 4, 5, and 6, and then we'll go over these together. And again, rounding is very important because your calculator is just going to throw out a bunch of numbers at you, and you have to decide which ones we're going to keep and which ones we're going to round. So try these, and then we'll go over this. Okay, let's go over these. 4 sig figs. So I'm going to keep 1, 2, 3, 4. That's where I'm going to draw my line. This 8 says round up. So I'm going to round this one up. So this one is 560. Oops, I didn't have to mean to put that there. 567.1. 5 sig figs. 1, 2, 3, 4, 5. I'm going to keep 5 digits. This 2 says leave it alone. So that means I'm not going to round. So it'll just be 400.34. 3 sig figs. There's my line. I'm going to keep these 3. This 3 says leave it alone, don't round. So it just becomes 90.4. 4 sig figs. There's my line. It's a 0. Nice. I don't need to round that. 100.0. Okay. So now when we do this, check. Check and make sure your number of sig figs are still correct. This is 3. This has 1, right? And if you're not sure, remember decimal place is present. Doesn't count, doesn't count, doesn't count. 1 sig fig. 4 sig figs. 1, 2, 3, 4. 5 sig figs. 1, 2, 3, 4, 5. 3 sig figs. 1, 2, 3. 4 sig figs. 1, 2, 3, 4. I think it really helps at the beginning to actually write all these numbers and put those lines and everything. Pretty soon it's going to become so natural to you that you're not even going to have to think about it, and you're going to be able to see your sig figs and do your rounding just like that. But right now, just to beginning, just so we're trying, I would keep all that on there. Okay, important. Your calculators don't know significant figures. They're just going to shoot out a bunch of numbers. You have to decide in the end how many significant figures to use, right? So every time you finish a calculation at the end, we need to go, okay, how many significant figures should I have? Do I have to round? And do I have the correct number of significant figures? And we don't do it until the very end of our calculation. Okay, so we're going to just do a couple practice ones. Okay, that's what my calculator says. What should the answer be? My calculator says 7.222, but I don't have that many significant figures. So when we do this, right, 7.2, right, this has 2, this has 3, so this can only have 2 significant figures. How about our next one? That's what my calculator says. How many significant figures? What should my actual answer be? So this one has 3, and this one has 3, so I need to have 3. So when I do this, I'm going to draw my line. What does the 7 say to do? Right, the 7 says round up. So when I do this, I get 0.108, right? And this is what I mean by your calculator doesn't know significant figures. So the very last thing we're always going to have to do is figure out significant figures. So for this one, that's what I got. Okay, how many significant figures can I have here? So if we look, this has 2 significant figures. This has 4, and this has 2, which means, yeah, we can only have 2. So if we can only have 2, I'll draw my line there. This says leave it alone, and we end up with 6.8 times 10 to the negative 3. So that's our significant figures. Now, one little piece of thing that I want to remind you, and I'll keep reminding you of this, and some of you have already seen it already. When you're putting these in your calculator, sometimes we forget to write them, right? So sometimes we forget, like if your answer is like 6.02 times 10 to the 22nd, I'll see people giving me this answer. These are very different answers, right? Just remember, because some of your calculators show this at the very edge of the screen and you forget this piece right here, right? So just as a caution, just make sure when we're using our calculators, and I'll say this again because it's such an easy thing to just forget to write this piece. So I'll remind you of that. It happens all the time. Okay, so